Okay, I think we can start now. So, good morning, everybody. So, in the previous lectures, I explained the way we create the internet is, number one, we have different autonomous systems, okay? As I told you, for example, if every autonomous system is an like organization, institution, for example, like Qatar University can be one autonomous system, okay? And then we connect these autonomous systems together. So every autonomous system is actually is owned, is under the administration of one entity. For example, Qatar University is the owner of this network. Is that okay? And also, as I told you before, one of the beauty of the way the IP addresses are created is I don't need to know the details about how you create the subnetwork inside your autonomous system. All what I need to know is just the network address. Okay. So, and then I told you here, usually inside every autonomous system, we use distance vector or we use link state protocols. Here, the protocol we use here inside the autonomous system, we call it intra-ES. And last time I explained OSPF and also RIB, RIB. Okay. So today, and also we need another protocol for routing here in to connect the different ES together. So to connect the different autonomous systems together, we need like a network of routers this way, and we need a protocol to deliver messages between different ES, and this protocol is called inter-ES protocol. And as an example for this protocol, we are going to explain today BGP. What's really important today, we should understand why we need two different protocols. You will understand today why they have to be two different. They have to be two. I can give you a short answer now, but you will understand better today. The reason, as you will see today, here, the network here inside one ES is actually, it is owned by one administration, one entity, okay? So these protocols mainly care about performance, as we explained before. So I need to find the shortest path, the least cost path, as I explained before. So we need something like that. However, this protocol, BGP protocol, is different. I may not care much about the delay. I mean, this is not my first priority. My first priority is I forward here packet based on what we call policy. So there is a certain policy we have to use. For example, this router is gonna forward packets coming from ES2 because I'm gonna get money out of it. Okay, but if I get something from ES3, I'm not gonna forward it because I'm not gonna benefit from doing this. Okay, so performance is not the main thing here, but we have something we call it policy. And policy, you can define it as you want. So in this policy, I'm gonna say which data, okay, so the data coming from which ES I can forward, and which data from which ES. So you can, this is one way to do it. We can have like a list of ES, okay, for I can forward their packets and others I may not, okay. That's why you will see that here the protocol is mainly, we're not going to look for least cost path as we did before, but mainly my first focus is policy. So let's see what I said here. So BGP is actually border gateway protocol. There are for sure other protocols. It is used to hold the ES network together. And this one, it is based on reachability information and also based on policy. That's what I explained, reachability and policy. Here I explain several messages we have in BGP. The first message, we call it open message. And this one here, one router communicate with a neighboring router to create TCP connection, and they authenticate each other. And then the other side has to send keep alive message. Okay, and from time to time, periodically, So routers actually periodically have to send some kind of hello message. I want to make sure my neighbors are alive. I have to make sure when I send a message to my neighbor is alive, or it can work or can forward the messages. So from time to time, here every router actually continuous monitors the reachability of neighboring routers, and actually they send like keep alive messages. Then once a connection is established, connection between each router and next router, we send update messages. So here in update messages, this one has the routing information. Also, we have also notification message. Notification message is seen when there is an error, or something like that. So again, every router has to create a connection using TCP connection with the neighboring router, okay? And then, as I told you here in the update message, you have to send the routing information. So what do you mean by the routing information? For example, here, if I send here, when ES3, for example, advertise a prefix for ES1, okay? That means ES3 is willing to forward any data to ES1, okay? So yeah, so here when I forward to my neighbor, I can reach to ES1. That means I'm telling my neighbor, yes, I can reach to ES1. That means I'm willing to forward data to distinct to this ES1, okay? This is how we can, okay, what if, for example, I have another neighbor here, ES7, for example, but I don't want to forward packets to ES7, mainly because, again, the idea here is mainly based on policy. Policy means, as just an example, it's maybe money related. So I'm gonna get money if I forward packet from here. I'm not gonna get money from here, or I prefer this one over this one, whatever the reason is, but based mainly on policy. So if I have a neighbor here and I don't want to forward messages from this one, so I'm not gonna advertise. This route again. So that means what I want to say is, if you advertise a route, that means you are willing to forward packets. So your policy is okay to forward packets from this ES. Okay. Now here we have two types of information. As I told you before, so for example, here, this is ES7, ES1, ES3. We have border routers. As I told you before, these are border routers, okay? So we need, number one, we need information here. We call it EBGP. So EBGP is actually, is information between this router. So let me go back to the picture. Yeah, I did here. So here, so we have we need two types of information. The first one is actually the reachability here in this area, in the connection between these different routers. That's what we call EGP. The other one, yeah, so here between the border routers. The other one here also we call it IBGP. So actually, IBGP is actually information has to be here inside the ES. Why we need this information? Simply because, for example, when it ES3, when it has to know to do that, I have to send data to 1C, not 1B, because I have two border. In this example, I have two border routers. So if I want to send something to ES3, this router here, these routers are not border, but they should know which border routers they have to use to forward data to ES3 or ES2. Okay, so that's what we call IBGP. So we have two types of information here. We have E, and I. So I here, as I told you, this should be, we need to tell the internal routers here which border or boundary routers they have to use to forward when they want to send data this way or to this ES or this one. Okay, but the other one here, we need to exchange information between the border routers themselves. Okay. So for example, here, if I wanna, let me go back here. Yeah. For example, here, if I wanna forward data from this router to this router, which path I have to take? Okay. But this is the other one here is internal here. One more thing here. Again, there are two main differences between what I explained to you before in routing regarding distance vector ALS and this routing protocol. As I told you, number one, this one is policy based. It's not based on the shortest path or the best path. No, it is policy based. Okay. Number two, here, this one is actually path vector routing. What do you mean by path vector routing? It means, you know, when I explained DV or LS, I explained what kind of information we need to share. Here in PV routing, we have to, you can tell from the English name. You remember DV means distance vector, because I have to share the distance from me to every destination, right? But this one path vector, that means here you actually advertise, or the information you share is actually the complete path. That means I can know the complete path here. If I am AS number X and I want to forward to Z, I know the complete path here. And why we need to something like that? We need the complete path for two reasons. What is the main reason is actually, as I told you, because of the policy. So for example, here, when I receive a complete path, and I'm gonna look at my policy. If my policy allows to forward packets to this ES, okay, I will do that. If not, so I'm gonna just discard this path so I can see the complete path. Okay. This is one thing. The other thing, for sure, it can solve the problem, count to infinity problem, because you have the complete path. Okay. So here, yeah. For example, here, every router can create something like that. I can create something like this. If I want to go from here to AS1, I can go directly. If I want to go from here to here, I have this space here, or I have this space. You can use a complete path. Okay. So now, when AS gets a route, when I get a route from my neighbor, I'm gonna check this route. Okay. I'm gonna see if myself in this path or not. If I'm in this path, I'm gonna reject it to prevent loops. Okay. If no, so I'm gonna update my routing table, but I have to check. I have to see if this route complies to the policy or not. Okay. Yeah, that's what I explained. BGP route selection. We are going to select here routes based on policy. Router may learn more than one route, and then you can make a preference to these routes. So I can have multiple options. Then I'm going to prefer this one, and then if this one fails for some reason, I can use another one, and so on. Yeah, so we need to check here if this path approved with the list, or here the list of approved is. Okay. Again, it's everything here is mainly about policy. So policy here, preference for is presence or absence of certain is. This is the meaning of it. So if some is present or some is should be absent from this. For example, here, one of the policy is never use ASX. Okay. For example, I'm not going to get any revenue out of this one, and so on. As I said, when you advertise a path, that means you are willing to carry traffic for this path. One more thing you should know here, these policies are not part of the protocol. So this is something the administrator has to configure the routers with this policy. You got what I'm saying? So the protocol doesn't tell what kind of policies? This is something you need to enter, or something provided to the protocol during the configuration. Okay. Yeah, so here policy routing can be easily implemented through path vector because you know the whole path. Okay, so okay, so again, it's not gonna be the smallest number of hops. It's not gonna be based on the minimum delay. No, it's mainly this one is here routing here mainly based on the policy imposed on the router by the administrator. Okay. Yeah, I think this is the last slide I have here. Again, I think I almost explained everything here. You should understand routing inside ES is different from between different autonomous systems. Why? Inside ES, as I told you, this is my network. I'm gonna forward all the traffic in this network. It's my network, you know what I'm saying? But here, if you want to forward traffic, if you want to put traffic between different autonomous systems, so there should be some policy for that. Okay, or I have to decide if I should forward to someone else or not. Okay, so here in intra we focus mainly on the performance because I'm gonna forward all data because it's my network, right? But for inter, mainly the performance here is actually, or the metric we're gonna use is actually policy, monetary factors. Okay, maybe dominate over performance. Okay. You should intra is actually single administrative with only one administrator. But here in inter here between different autonomous system, you should have control over how its traffic routed, who routes through its network and so on. Okay. Still, we use also hierarchical routing here to save the tape. I think this is the end of this one. Now I'm gonna talk about the. Okay. So now I'm gonna talk about final exam, or what should we do now? I'm expecting from you number one, homework 2. Okay. Number 2, we need, as I told you, I need the report, the project report. Either today or the last time during the exam day. Okay, please don't. I'm not gonna take it after the exam day. Okay, the final report. Also, I told you in my emails, I'm gonna grade the report out of 80. Also, you need to give me a link you have to email me a link for a presentation. This presentation you don't need. You don't need to show faces. Just make a PowerPoint, explain how you did it, explain how you got the results, and how you interpret the results. Okay, this will be 20% of the project. Also, we're gonna have one quiz today, quiz number 5. I told you this is optional. I'm gonna grade all quizzes, but I'm gonna take the best 3 quizzes out of 5. Okay, and also we're gonna have a final exam. That's all what we have. But let me just before I take your question, I think the final based on the, if I'm not mistaken, this is from the university website. I think this course here will be in this room. This is L53. So this one will be 4th of June. Is that right? Yes. Okay, 4th of June is going to be from 8 to 10, 2 hours. Yes. What is it? The meeting. How long to be? Report? The meeting. 15 minutes should be no. I'm not going to ask for 2 hours. So 15 minutes, 16 minutes should be okay. So yeah, now I'm going to talk about the final exam. The final exam, let me go through the here. Yeah. So as I told you before, the final exam will cover chapter 5, 6, 7. Okay, it's not gonna the first chapters. The first chapter are not in the exam. So for this one, you have here, I think, explain several things here. Framing. What is framing? What is error control, flow control? Yeah. So everything. So the final number 1. all numerical examples in all chapters are important. Numerical, all numerical examples are important. This number one. But the exam also, in addition to numerical examples, the exam also can have some verbal example to ask you some question to understand your understanding to the concepts and to the topics. So yeah, I think everything here, I can't cancel anything here. Everything here is needed. I can tell you if anything is not needed, I'm going to tell you about it. But I think for this chapter, yeah, for this chapter, it seems to me it's just very easy chapter. Yeah, so this chapter, it should, it's okay. Yeah, the complete chapter is here. So let's see the second chapter here. You should understand how the protocol works. You got to think how it works. Yeah, what is that? Theoretical. Yeah, theoretical. Okay. Yeah, so figure here is actually explaining how it works. You got what I'm saying? So if you understand how the protocol works, you should understand the figures. You got what I'm saying? But we want to about something different. You should understand how the protocol works. You got what I'm saying? You don't need to memorize these figures, okay? You don't need to memorize them, but you need to understand how it works. Is that okay? You don't need to memorize the figures. I'm not going to ask you to draw any figure, these figures, okay? But you should understand how every protocol works. For the second one here, the medium access control, again, all numerical examples are important. I think maybe there is something here I can cancel. You don't need it. So again, I think you need everything here. Numerical examples are important. The only thing I can tell you here, we don't need it. It's just here. For example, here, time division multiplexing, and this we don't need them. Only we are going to need here CDMA. So for channelization, only focus on CDMA. Okay, just this. Also, I think also, yeah, you can cancel the controlled access. We don't need it. Controlled access as well. So this one, okay, and also, yeah, so controlled access, we don't need it. The controlled access, this one, and also we don't need TDM and FD. CDMA will be in the exam, okay. You have numerical examples here. All of them are important. Yeah, so here in CDMA, you should understand how it works, the idea of using chips, the idea of it, and what are the requirements for the chips. The chips cannot be random numbers. They have to achieve certain requirement for the protocol to work. Okay, so this is what I explained here. And the last one here, also you need to know this one, Walsh tables. Walsh tables is, as I told you, it's just a simple. It's one way to create, to calculate the chips, as I told you, right? And I told you this table, and this table you can create for sure 1 or 2, 1, 2, 4, and then after 4 it has to be 8 because it has to 2 to the power of something. You got what I'm saying? So that means this one is used if you have 2 computers because you have 2 chips. Here, how many chips you have? 1, 2, 3, 4. You have 4 computers. So this is one chip. So from this one, you can easily create W8, right? After 4 W8 using what I explained. Okay. For the last, for chapter number 7 here. Okay, there are maybe many things I'm gonna cancel here. Again, let me go to the beginning. I think we still have time. Should be okay. Yeah, so you need everything here from the beginning. So is it, how this, if I give you any address, you should be able to know the class based on what I explained here. You should be able to know the network. Once you know the class, you can know the network address. Okay, you can easily know the network address of the IP, as I explained here in several examples here. Subnetting, I explained it. I told you why it is very important. Masks, how can you use masks? All of these are important. Yeah, so all of these are important. What I can tell you here, Also here, how you assign. So everything here is important, but here for routing tables here, you should understand how they work, okay? Distance vector and link state, but in the exam, I'm not gonna give you something like that and then ask you to make the routing table. You don't have, I don't think you have time to do that. You get what I'm saying? So you should understand how it works, but I'm not gonna ask you to make a routing table here, okay? Same thing for the other one. For the, yeah, you need to know what information we exchange. Same thing here. You should know how it works, but I'm not gonna do like the homework. I'm not gonna give you one and then I'm gonna ask you to make the routing table. You don't have time during the exam to do that, okay? Comparison is very, you should understand the count to infinity problem. You should understand what is this problem, how we can fix it, what is the reason for this problem. Also, the comparison is very important. That's all what we need. The comparison is very important. That's all what we need in this chapter. So this part is not going to be in the exam. Is that okay? So you don't need anything after this one. Hierarchical routing, even what I explained to you before, you don't need it. Okay. Any questions? Okay. You said you need yeah. Unless you have to yeah, one can go exactly to the understanding not that's one, but the other one is short. But you want to about what yeah, but one directly connected to the solver, but the other one is through multiple routes. Okay, again, I got the question. So I think we have something similar here. Because I got this in the homework. Yeah, we have. Okay, okay. So for example, let me answer this question to start the quiz. So for example, from U to W, the cost is 5. Okay, but if I take this route this way, the cost is 3. So which one is better, 3 or 5? It's 3 better, but this one goes I'm gonna do this. Okay. You got what I'm saying? I got your point. Your point is that it's gonna go through 3. Yes, it's gonna go through 3. But for example, the code given, the code is a delay. The delay is a delay. If the code is bandwidth, the bandwidth will be better. Why not? Okay. However, if we use it, if we make, can you be silent, please? And here, if we make all the costs are once, so in this case, what again, the least cost path is actually the shortest path. You got what I'm saying? If you wanna select the shortest path, you have to make all costs are once. Another question about the LS. About what? The LS. The LS, it's looking for the full system, right? Yes, I have the same. Okay, does it choose it's not this part or it's trying to be choose the no, it's the same thing. You got the same code. Yeah. You got the same stage. I can almost I can see the least code. It doesn't, we don't care how many routes we go through. We don't care. Okay. If you want to say still you are confused. If you want to say the short bit, so all topics have to be one. Okay. You got that sense? Excellent. What is the, excuse me, what is the quiz? No, I'm sure. What is that? Okay, because can you wait until the end of the class? Okay, please. This is something you need to figure out. You can understand? It's something I should not tell you. It's something you need to tell you. One of the questions I asked you, what is the first address and not address? Don't forget to write your name.